Hi everyone, it's Coach Fred here. It's late night, and today I wanted to make sure I got in today for you a quick video on solving basic log equations for the ACT. So I wanted you to remember when you're solving a log equation, there is a domain restriction, and so the value of x can never be less than 0. And so they're going to state that. They're going to say for all x greater than 0, and it shouldn't stress you out. It just is telling you the domain restriction. But the definition of a log is a power to which a number is raised in order to get some other number. So if I give you I don't know, log base 2 of 4, this is actually saying 2 to what power equals 4. 2 to what power equals 4. Now, in your Algebra 2 class, your teacher probably told you set it equal to x and write it exponentially. Some teachers call that the fish hook method. I call it around the world to just make sure you see. So then 2 to the x equals 4, so x would be 2. And let's answer that question. 2 to what power equals 4? So 2 to the 2 power equals 4. And so let's go back to that domain issue. If I gave you log base 2 of -1, 2 to what power would give you -1? Well, there's no value that I can raise 2 to that's going to give me -1. Even if it's a negative exponent, it's just going to give me a smaller fraction. So that's why they state that and why it's important for you to understand basic logs. All right, well, let's just look at some basic log equations. So here we go. For all x greater than 0, again, they're stating the domain. What is the value of x? So let's think about the definition. 5 to the 4 would give me x. So 5 to the 4 is equal to x. So 5 to the 4, you grab your calculator, is 625. All right, I can move the x around. For all x greater than 0, find the value of x. X to the 5 power equals 32. So it's saying what number raised to the 5 is 32. So 2 to the 5 power is 32. A little harder. Log base 6 of x equals 2. So 6 to the 2 equals x. Actually, that's not harder. 6 to the 2 is 36. Equals x. So x is 36. Now let's write that separately. What if we just wrote it like this? Again, the definition of a log is 6 to what power would give you 36. And so you can see now that it is 2. All right, a little bit more challenging. 5 to what power gives you root 5? So again, thinking back to your algebra class, you could set it equal to x, and you get 5 to the x equals root 5. Well, this is harder only because you have to remember some specifics about root 5. Well, if I want to write 5 with an exponent, root 5 with an exponent, I would write it as 5 to the 1/2 power. So using the 1-to-1 property, x would have to equal 1/2. Thinking about the fact that equals means is the same as, if you have 5 to the 1/2 over here, it would have to be 5 to the 1/2 over here. All right, a little more challenging, log base 2 of the cubed root of 8. Okay, so that means 2 to what power equals the cubed root of 8? Okay, I'm going to take a step back before I do this. What if I said to you log base 2 of 8? Well, you'd set it equal to x. You'd write it exponentially, 2 to the x equals 8. And you'd solve it as an exponential equation. You want to make the bases the same. Right now, you have a base of 2 on the left and a base of 8 on the right. Is there a way for you to write the 8 with a base 2? I think so. You could write it as 2 cubed, right? So, as soon as you write it as 2 cubed, using the 1-to-1, x would have to equal 3. Okay, so now let's go back to our problem here. Now we've got 2 to the x equals the cubed root of 8. So I have a couple of options. I could do 2 to the x equals 8 to the 1/3. I could work backwards even more and write 2 to the x equals 2 cubed to the 1/3. And I could say 2 to the x equals 2 to the 1, because power to a power you multiply, so x equals 1. That's one way you could think about it. You could evaluate the cubed root of 8 right away and say that it's 2, and so 2 to the 1. So you're seeing multiple ways that you can come up with an answer. That's what we want on these tests. We want multiple ways to kind of approach a problem. So I'm going to give you one more. What if I gave you log base 2 of the square root of 8? So you certainly could set it equal to x and write 2 to the x equals the square root of 8, and 2 to the x equals 8 to the 1/2. Oh gosh, and then 2 to the x equals 2 to the 3 to the 1/2. Power raised to a power you multiply, so that would give me 2 to the 3/2. So x would equal 3/2. So you could do it like that, but you could also use something you learned in algebra called the change of base. Your calculator could help you. And I love when we can actually think about using our calculator on the ACT, because the ACT lets you. Well, using the change of base says that if I have log base a of b, then I could put it in my calculator by writing it log b over log a. So in this case, I could write, I don't have to set it equal to x. I could use the change of base and see what happens and get log root 8 over log 2, getting 1.5, which is the same as 3/2. So that would be a nice, quick, easy way if you remember the change of base. The change of base formula is a way for you to take a log expression and make it a log base 10 so you can use it on your calculator. All right, so that was just a quick video on the basics of logs. Hope that was helpful, and I hope you have a great night.